Hi guys, I'm Emma and today I'm going to talk about natural language processing and censorship for kids. So we're going to talk a little bit about how natural language processing works, and then we're going to apply those topics to censorship. Censorship is a great way to talk about language processing because when we censor something, we just look at what somebody's saying and then we have to decide what it's about and if we're going to allow that publication or not. And doing that requires algorithms that can understand text. We're going to talk about this in the context of China because there's a lot of censorship going on there right now, and it's a really good use case. Because we're talking about China, we are going to be using Mandarin as an example, and even though I don't speak Mandarin, I think looking at another language is a really great use case to understand the full NLP process and all the different options that we have. So the first thing that we want to think about when we are analyzing a language is figuring out where the words are. And this might make a lot of sense to native English speakers, but if you write in a character language, it might not so much. So here we see a sentence that I Google translated. As a disclaimer, I do not speak Mandarin, so I'm sorry if I translated this wrong. It says, "I like ice cream." And here it came up with the characters. And it's hard to tell which word is which because in English we use spaces, but in Mandarin, that's not something that we use. We don't use this delimiter. So we're going to use a technique where we check combinations of characters. This is something we call engrams. And we're going to check all those combinations of characters within a dictionary. First, we'll start with 5. Engram is 5. And then we'll do 4. So the first 4 and the next 4 and the next 4, all the way down to 1. And this is going to help us sort out which words are where. So once we figured out where our words are, we want to figure out what part of speech they are. And again, this is something that's a little bit different in Mandarin than what we might be doing in English. So in English, we have a lot of different words that we use to describe essentially the same idea. If I want to say destroy or destroyed or destroyer, those are all going to be the same character in Chinese because at the end of the day, they're more or less the same idea. So tagging what part of speech different characters are can be more tricky, and it relies more on context than it might in English, where things can be a little bit more cut and dry, at least comparatively. So a third thing that we need to think about when we're looking at the Mandarin language is how we're going to process date times. It might seem like a nitty-gritty thing to address, but think about the Lunar New Year. Every year the Chinese New Year is on a different date, at least for those of us that follow the Western calendar. And this is something we have to take into consideration when we're processing languages. China uses both the lunar calendar and the 12-month calendar that we use in the Western world. So making modifications like this and making sure that everything is on the same calendar and using the same date time structure is super important for when we go to process all that data. So once we've figured out what words we have, we want to start encoding things. At least from the perspective of the Chinese citizen, their goal is to post something on a social media platform, maybe WeChat, for their friends to see. And maybe that information is about a politician or some other censored topic. And they want to be able to communicate and get that from point A to point B without it being caught in the middle ground of censorship. So the goal here is to encode our language so that other people can understand it, but that machines can't. And this creates a cat and mouse type game. One of the easiest ways that we can encode language is just by creating nicknames. One of my good friends' names is Jonas, and we all call him Jojo. And we can do the same thing in Mandarin. If somebody's name is Yang Mi, we can just call them Mimi. And because we've changed the name, algorithms aren't going to pick up on that, and hopefully that material is not going to be flagged anymore. Another way that we can encode information is by using homophones. A homophone is a word that is spelled 2 different ways and has 2 different meanings, but sounds the same. A good English example for this is the word but. We have B-U-T and we have B-U-T-T. And these words mean 2 different things, but and but sound the same. And this is a great way to encode language. So here we have more Mandarin. First we have Shengfu, which means government in Chinese. It's 2 characters, Shengfu. And what we want to do is figure out all the ways to pronounce Shengfu. And like in English, there's a lot of ways to make the same sound in Mandarin, right? In English, there's a ton of ways to spell any given sound, and it's the exact same in Mandarin. You're just going to use characters instead of letters. So for Sheng, we have all these, And for fu, we have all of these. And what we're going to do is we're going to combine one pronunciation of sheng and one pronunciation of fu, and then another and another, and make all these different mismatches of ways to pronounce it. And then we're going to rate how often these are actually used in everyday Chinese. Because what we don't want is to use complete nonsense words. And what we do want is for people to be able to understand it, even though maybe it's not spelled correctly. So we're going to use the top rated, the most frequently used mixes, and then we'll use that. So we have a new word that's still pronounced sheng fu that maybe doesn't have the same meaning, but studies show that when we encode like this, 99% of native speakers can understand it perfectly. So homophones are a really great way to do that. Let's see, what else? So now let's talk about how on the hand of government we can decode information, right? We've talked about some of the ways that we can encode information, but now we want to figure out how to actually flag information for censorship. When we're flagging information for censorship, essentially what we're doing is classifying it as something that should be censored or something that shouldn't be censored. And most often, the times, the words that need to be censored or that are being censored are metaphors, right? They're nicknames, they're combining different word combinations that might not normally make sense, and simply put, they're uses of speech. So we want to flag all of these. And for this, we can use linear classifiers. Linear classifiers are things like regressions, and they're just going to say yes or no, 1 or 0, binarizing, right? It is or it isn't. So we can use the linear classifier. We can use something like maximum entropy. That's just another algorithm. Understanding the nitty-gritty of how these techniques work isn't as important as understanding the big idea that we're just trying to pull out metaphors, not metaphors. So here is one way that we can do this, and this is called common semantic functions. So what we're doing is seeing where we have the different parts of speech. So I wrote 2 sentences here. The first, I drove to the store. I have my subject, my verb, and my object, and this is a literal sentence. It means I'm driving to the store. And then I have, it's raining cats and dogs. I have the subject, the verb, and the object again. And the order that we write this in doesn't really matter as long as the sentence makes sense. But this one is metaphorical. And the way that we can tell it's metaphorical, at least from a machine's perspective, is saying, okay, how often is cats and dogs associated with raining? Not that often. Most likely saying that the raining is happening with the cats and dogs is most likely going to be a metaphor. And so that's going to flag that, and that is how censorship works. And on top of all of this, it's important to note that censorship is constantly changing. We see that one of the biggest issues with keeping up with this field is that people keep learning how to encode language in new ways, which means that training models to learn this they're always going to be a step behind. So I hope that you guys learned something about censorship and natural language processing, and yeah, I'll see you next time.